So next we have Emma Foley talking about testing infrastructure and services in OPNFV.
Thanks, Ray. And I'm not talking just about testing your infrastructure and services in OPNFV. Actually, the point of this talk is to show you how you can use the OPNFV test tools to test your own infrastructure, regardless of whether you're already a user or whether you deploy in really large environments or are just interested in benchmarking small components. So there's typically two goals to this talk. First, to create awareness of the OPNFV test tools. We want to target users who are already looking at NFV deployments, but also users that are interested in other kind of use cases outside the NFV domain, because we think these tools are actually quite useful even outside NFV. And the point of this is to try and trigger discussion about the evolution of these test tools and find out how they can evolve and how they can be modified to meet existing use cases and also to address some emerging ones, like, for example, cloud native, edge computing, perhaps things like enterprise or IoT, and definitely a lot in the SDN domain. So for anyone that's not familiar with OPNFV, it's the Open Platform for Network Functions Virtualization. It's a Linux Foundation network project, and it provides system-level integration, deployment, and testing. So basically what we do is produce a reference platform for NFV and also produce requirements for other upstream projects for extending those with features that make them more NFV friendly. So something like this. We provide requirements and features into the other upstream projects like OpenStack or OVS, and then we implement those features and update installation tools to actually be able to configure and deploy these features. And then once we have that deployment created and deployed, we take our tools and we run various functional and non-functional tests against these deployments. So typically the tests will cover all kinds of resources in the stack. So we're talking about VNFs, Mano layers, Vim layers, also a data plane. And as part of the OPNFV Community Lab, there's a lot of donated hardware in different Pharos labs around the world that allow you to reserve some time and actually use some community hardware to test these features or to help develop your features in upstream projects. Okay, so in terms of test tools, our test ecosystem looks a little bit like this. We have functional testing in the form of Functest, and then a bunch of performance and benchmarking testing split up like so with these other projects. And one use case for these is actually in the OPNFV compliance and verification program, known as Dovetail, which consumes tests from all of these components and lets you run this test suite against your deployment to know whether or not you actually meet the requirements to run certain NFV workloads. Okay, so I'm going to start off with Functest. This is our functional testing tool. And what Functest does is it allows you to run functional tests against your Vim. So that may be Kubernetes or it may be OpenStack. And Functest doesn't actually provide a lot new. What it does, it gives you one tool to use to be able to run tests across multiple standard OpenStack tools or multiple standard Kubernetes tools that are used. So for example, in OpenStack, the Functest test suite would consist of a lot of Tempest, Rally, Shaker tests, and a bunch of others as well. So it just gives you one source, one point, or one interface to use to actually test these systems. There's also some VNF testing in there as well, and in terms of Kubernetes, it at the moment just supports the I think 1 or 2 standard set of tests. But upstream in the OPNFV CI, this is run. This is run against our daily builds, and it can be run in your deployment from patch set verification all the way up to nightly builds and release gating. In terms of how it's packaged, if you want to use Functest, you can pull down a Docker container and get started immediately, and there is some very, very comprehensive documentation available on the wiki. Let's see if I gotten everything. Yep. Does anybody have any questions at this stage about Functest? Comments? No? Okay, well, next up is Yardstick, and Yardstick is the infrastructure verification project within OPNFV. And Yardstick consists of 2 parts. There's a set of test cases that it actually runs, and also there's Yardstick as the framework, which is the part that you can extend to meet your own use cases. So in terms of framework, Yardstick provides a bunch of test functions, such as scenarios that let you customize your test steps, and also if you want to integrate some additional test tools into it, this is a point of extension. It supports running tests in multiple different contexts, so you can run it against a Kubernetes or an OpenStack deployment and have those provision your environment for you. Or you could say, hey, Yardstick, I have some hardware over here. This is where you run the tests. There's also a number of test runners that let you define how the test is actually run and when to collect the metrics during the test. Yardstick is a benchmarking tool, but it can also be used to do some functional testing as well, and also provides the ability to define certain service level agreements, or SLAs, to determine whether or not your system passes or fails. And it also supports reporting of results through InfluxDB or as JSON format into a file, and also reporting over HTTP if you want to integrate it into your own systems. The second part of Yardstick is the test cases, and these are already existing test cases. They're defined in YAML, and we make use of the Jinja templating format so that you can actually take existing test cases and modify those instead, edit the parameters to actually meet your testing requirements. The same as Functest, it is packaged in a Docker container, so you can pull that down and use it. And we do collect performance metrics using Yardstick, and there's also the ability to use something like collectee or barometer, which is OPNFV's extensions, to collect NFVI metrics while you're actually doing testing on different parts of your system. And there are some already existing use cases and already different scenarios that we already test. So if you wanted to pull down Yardstick now and use it out of the box, you can do things like high availability test cases, which basically says, hey Yardstick, start taking down services. I want to see how long it takes to recover. It also integrates a number of the other test tools in OPNFV. So Storeperf and VSperf have some integration in there, so you can use Yardstick to run those tools as well. And it also supports NFVI and VNF characterization as well, which provides you automations on top of a number of traffic generators, and also supports a bunch of reference VNFs and also commercial VNFs if you want to do characterization of those. That's Yardstick. Does anybody have any questions at this stage? Okay, so next up is the Bottlenecks project, which does system limit testing. And Bottlenecks aims to identify bottlenecks in your performance. It does this by consuming test cases from some of the other test tools, so it'll consume some Functest test cases, Yardstick test cases, and also some NFVbench test cases, and we'll adjust the parameters of those to design some very stressful tests. And then you can think of Bottlenecks as a scheduler, because it'll run those tests multiple times, either overlapping or over long periods of time. There's a lot of flexibility there. And it will collect metrics while it's doing this from Barometer and Prometheus. So if you're using, for example, OpenStack, you can also pull a bunch of metrics about how the OpenStack services are doing, as well as seeing what's happening with your infrastructure and getting metrics from things like your deep decay or OVS or memory, CPU, and other system resources. And Bottlenecks will integrate this into a Grafana-based dashboard that you can actually use to quickly pinpoint the pinch points in your system. Let's see. Yep. It collects metrics and produces also a pass-fail output. You can use this from a Docker container as well. This is a way that most of the test tools are actually packaged at the moment. And in terms of extensibility, you can add more test cases to it, or you can modify the test cases that are there to meet your own requirements. And if you have other test tools, it's a fairly straightforward process to actually integrate those into Bottlenecks to use it for the system limits testing. Does anyone have any questions about Bottlenecks? Okay, moving on. Oh, Chris has a question.
Is there a dashboard? Can we go and have a look at how certain things run and...
There is a dashboard. We cannot go look at it now.
Okay.
But if you go to the Bottlenecks wiki it's part of the OPNFV wiki, they provide a list of instructions and also how to use the dashboard as well. And I believe there are a few demo videos as well. So next up is VSperf, which is one of the two tools we have for NFVI data plane performance. And VSperf it's used for optimizing the performance of your vSwitch. It lets you test out different configurations in your environment to determine what's the best configuration for your vSwitch. This is done before you start deploying any kind of VIM on top of it. This is base level performance tuning for vSwitches. There's a number of vSwitches supported, but also you can run you can use VSperf with a number of different traffic generators to actually do the load testing on the vSwitch. It's generally run in a pre-production environment and actually has been responsible for the development of two new standards that came from its actual implementation. So there is vSwitch performance benchmarking. It's an informational RFC, and there's also a new one that's under review at the moment, TST009, which takes into account benchmarking your vSwitch, but also taking into account intermittent failures that may happen in your system, like that are not constantly there. excuse me. In terms of traffic generator support, you can run your test cases with Ixia, Spirent, Tgen, Moongen, Xena, and I think 2 more, but it has very comprehensive support, so you can use whatever traffic generator that you want with it. In terms of usage, VSperf lets you choose your vswitch, your traffic generator, and VNF that you want to use your test case. And your test case can be simple 5-to-5 benchmarking, physical to virtual, or the physical, virtual, physical, so what some people call the bunny ears test, routing through 2 VMs. But if you want to extend it, you can support multiple different deployment options in VSperf, so you're not limited to the set that's there. You can define other traffic routes or service function chaining and use different VNFs as well. Let's see. Hey, does anybody have any questions at this point? No. Okay. Next up is NFVbench. And this is slightly different from the other tools in that it's designed to be used closer to production. And it's used through OpenStack systems and does a full stack testing of your network performance all the way through your system. It's designed to be used very late stage pre-production, so day 0 capacity testing, but also when you're considering extending your deployment for capacity planning, NFVbench is used there as well. It's distributed in a container, which contains NFVbench itself, but also the T-Rex traffic generator as well. So you pop this onto your system, and you can do day 0 baselining, or you can do data plane performance monitoring for each deployment, like when you're verifying a new compute node, or you can use it, as I said, for capacity planning as well. Extensibility, you can modify the parameters of your test run. And I don't know if I have anything else on this. Because it's designed to be used close to production, NFVbench runs something that's similar to RFC 2544, but collects a few additional metrics, including collecting your partial drop rate, and that's something that you can configure during a test run as well, what kind of loss that you're willing to actually tolerate. So, almost there. The next one is, does anyone have any questions on NFVbench?
Everything is installed via Docker image, pre-configured and as well, and you can ready to run.
You can do additional configuration, but with most of the tools, they're good to go when you install the Docker container. When you pull it down, you may have to provide credentials and locations for your OpenStack deployment, though.
Okay, that's okay. That's fair enough. Just if you do nothing about the project, just playing around a little bit, that you can start with really quickly.
Yeah. Okay, next up is Storeperf, which measures the performance of block storage and ephemeral storage at a VM level. And this is again pre-production. The purpose of Storeperf is to report on storage performance after all virtualization layers are taken into account. So a typical test run with Storeperf involves spinning up a VM and running some very stressful tests to test the limits of your storage. So it'll take your continuous readings of your storage over time, and it reports once a steady state has been reached. And in terms of extensibility, you can modify the parameters, such as what you define as steady state. You can define a set of hysteresis or how long it's supposed to actually run for. And if you do end up running it and you don't reach a steady state, it lets you know that as well. Storeperf is distributed in a container, and it's currently following a continuous release model, which is distinct from the rest of OPNFV. So whatever hits master is usually good to go. So we talked about extensibility, and so yeah. Does anyone have any questions on Storeperf? Nope. Fantastic. Okay, so the last thing I'll talk about is Dovetail, which is the OPNFV compliance verification program. It allows you to verify that your commercial platform is actually OPNFV verified or meets the requirements that they've defined for NFV readiness. It is usually released mid-cycle, so there's a 3-month delay between OPNFV release and the Dovetail release. And the latest one was last September, so we're due an update. Dovetail will take a bunch of test cases that have been defined by Functest and Yardstick and perhaps a few others, and it runs these and reports on whether or not your platform has passed it. For the moment, they're focusing just on functional tests, because when you're talking about commercial platforms, performance tests are a little bit controversial when you're trying to define a standard platform. So that's it. Usually there's addressing original use cases, but that's not something we're going to cover in this. So does anybody have any questions about the whole lot?
What are the platforms which are already verified?
So the question was, what are the platforms that are already verified? I don't have the answer for that, but there is a OVP website that you can go to. That's the OPNFV verified program website, so you can see the results, because people will take Dovetail, they'll run it themselves and upload the results, and it'll be reviewed by community members before being published.
Some test is very close to what Ray presented just before with CC to the NVIO. So my question is, did you already meet together before?
Well, we're all part of LFN, and as part of that ongoing initiative, we are looking at areas that we can work together and combine and consolidate. But that's an ongoing process.
Are we running T-Rex in some of the... Are we using T-Rex as a tool in some of the testing?
Yep. Yardstick supports T-Rex, I believe, and so does NFVbench, and so does VSperf.
Yeah. So it's kind of integrated, at least through the toolchain. I don't know how much roadmap there is in the tests run, though, I don't know.
Mm-hmm. But yeah, the CSIC guys and the NFVbench guys do work closely together, but I think outside of that, not very much. Okay, thank you, everyone.